My names are Dr. Emovon, and the title of my paper presentation is the optimal siting of a nuclear power station in Nigeria using fuzzy Grey Relational Analysis. Presentation outline. The presentation outline is as follows. Background to research. This is followed by aim and objectives, methodology, case study, result and discussion, and finally conclusion. Background to research. Majority of the industries in Nigeria rely on individual power generating set for electrical energy production, and this is as a result of the inadequate and epileptic supply from the national grid. To solve the problem of power generation in Nigeria, there is the need for production of electrical energy from multiple sources, such as nuclear, rather than relying solely on fossil fuel. Nuclear energy is providing around 17% of the electrical energy need in the world, with over 30 nations already utilizing the technology. And one of the most important phases of nuclear power plant development is the selection of the best site for each location, because it will result to cost minimization and protection of humans and environment from the negative effect of the operation of nuclear power plant. Aim and objectives. Aim of this study. The study aimed at choosing the most appropriate state in the South region of Nigeria for siting nuclear power plant using the fuzzy GROA method in order to achieve cost minimization and protection of humans and environment from the negative effect of the operation of the nuclear power plant or station. The objectives were: 1. To determine alternative nuclear power plant site. 2. To determine decision criteria for evaluating performance of the alternatives. 3. Selection of optimal nuclear power plant site from among the alternatives using fuzzy GROA method. Methodology. The proposed decision system for evaluating the best state for siting nuclear power plant from among the 6 states in the South region of Nigeria is presented in Figure 1. The goal. The goal in this paper is the selection of the best state for siting nuclear power plant. The decision criteria considered in this paper are nearness to water resources, distance from populated area, risk of attack, and distance to industrial energy consumers. The alternative nuclear power plant site include Edo, Delta, Rivers, Bayelsa, Akwa Ibom, and Cross River. Finally, the best state is determined using fuzzy Grey Relational Analysis, and the state with the highest fuzzy Grey Relational Analysis performance value were selected. The decision criteria are described in Table 1. Nearness to water resources. For effective cooling of nuclear power plant, large volume of water is generally required. Thus, nuclear power plants should be sited near the sea or big river. Distance from populated area. The appropriate site for location of nuclear power plant should not be near populated area in order not to expose people to radioactivity risk of attack. Nuclear power plants should be located in a place that is safe from any form of attack, be it internal, from Boko Haram, militant, and any other pressure group, or external. Distance to industrial energy consumers to reduce energy loss in the course of transmission. The site for location of nuclear power plant should be close to large industrial energy consumers. The Fuzzy-Gray Relational Analysis Method. The Fuzzy-Gray Relational Analysis Method is a combination of the fuzzy set theory and the Gray Relational Analysis Method. The Gray Relational Analysis technique was introduced by Deng for solving multi-criterion decision problem. The ranking principle is based on the degree of similarity between the reference alternative value and each comparison alternative value. One of the limitations of the Gray Relational Analysis method is the utilization of only precise data in the decision analysis, but in reality, the use of precise data is inadequate. However, integrating fuzzy set theory with Gray Relational Analysis method make it possible to properly model ambiguities in the decision-making process. In the fuzzy Gray Relational Analysis method, linguistic variables are utilized by decision makers to assign values to alternatives with respect to decision criteria. The linguistic variables assigned by decision makers are normally converted to fuzzy triangular number consisting of three real numbers L, M, and P. The fuzzy-gray relational analysis algorithm consists of 7 steps, and it usually starts with the determination of the fuzzy decision matrix and ends with the evaluation of Gray relational grade. The Gray relational grade of the alternatives are generally evaluated by summing the product of criterion weights and the Gray relational coefficient. To determine the suitability of the proposed fuzzy-gray relational analysis method, a case of selection of the best state in the South region of Nigeria for locating nuclear power plants is utilized. The decision maker assign ratings using fuzzy scale, and the rating assigned to each alternative site are indicated in Table 2. Decision criteria weights are also required in the analysis, and as such, decision maker assign weight to each decision criterion using fuzzy weighting scale, and the weight assigned to each of the decision criteria are also presented in Table 2. However, to make the information in Table 2 suitable for use in the fuzzy-gray relational analysis, the decision maker's linguistic rating are transformed into triangular fuzzy numbers as shown in Table 3. Applying the fuzzy-gray relational analysis method to solve the decision problem in Table 3, the results generated are indicated in Table 4. From Table 4, the ranking order of nuclear power plant alternative sites obtained from the analysis is Delta, Cross River, Rivers, Edo, Bayelsa, and Akwa Ibom. Delta State, having the highest Grey Relational grade, is the best state for locating the nuclear power plant, while the worst state for locating the plant is Akwa Ibom. Conclusions. The paper aimed to apply the fuzzy Grey Relational Analysis method to select the best nuclear power plant site from among alternatives of Edo, Delta, Rivers, Bayelsa, Akwa Ibom, and Cross River. The performance evaluation of each state was determined based on 4 decision criteria. The result of the analysis indicated that Delta State is the best site for locating nuclear power plant among the 6 states in the South region of Nigeria. For future work, more decision criteria such as public acceptability and convenience of nuclear fuel supply can be included in the decision analysis. References. These are the references utilized. Thank you for listening.